Good morning. Thanks for making the effort to get here this morning after last night. And I'm Marina Kalkanis, CEO of M2A Media. And today I'm going to talk to you about what we've been doing with Apple HLS. So basically my talk will introduce who's on the team, what we're doing. I'll run you through Apple Low Latency very quickly. It's not a tutorial, but just some key points. I want to talk about how we put it into our workflow. Then I'll tell you about the integration and testing we've done, a little bit of how that's gone. And then finally, where are we on this journey? What are our findings and really what's the road to rollout? So who are we working with? One of the main parties that we're working on with this is DAZN. So can I get a show of hands, anybody who's heard of DAZN in the audience? So actually, it's not too bad. DAZN's making a name for themselves as the Netflix of sport. They're an OTT sports subscription service. They're global. They are all about live sport. And on a weekly basis, they're getting audiences, concurrencies in the millions to live events. And as we all know, streaming live events isn't easy. So with that, let me just give you a quick intro to DAZN.
Allow me to introduce myself.
And the feedback was, how come there's no video in your talk? So I thought, right, I can add video. Right, anyhow, so that's DAZN. And why are we doing Apple HLS? Well, as I said, DAZN's all about live events. And for a live event, latency is really one of the most important aspects in the quality of experience. Why Apple low latency? Well, because if you're doing live event, if you're doing sport, that's a big screen experience. And when you're doing it globally, you're delivering to a lot of iOS and Apple devices. So HLS is going to be a big part of what you do, and it is for DAZN. Yikes. Have we got feedback now? Right. Okay. So how do we fit in this? We're M2A Media, and basically we do the head ends for DAZN. So we're live streaming specialists, and we build all of the workflows that DAZN uses for their live streaming service. So I'll quickly now take you through the highlights of Apple Low Latency HLS. And particularly what I want to talk about are the things that we think are important and have really contributed to low latency in HLS. Probably partial segments is going to be right up there at the top of the list. You really have to get down below 6-second segments if you're going to do anything in the low latency space. Playlist blocking reloads is important. Particularly for our side of things, because we're not the CDN, and we don't want all those requests coming back to us. HTTP2 push, of course, is important because of the round trips and trying to get rid of a lot of that network delays, et cetera, with the round trips. Then a couple of the other things that Josh talked about last night with the playlist deltas and the rendition reports, again, really help because if you can get the parts out there fast, that's great, but you have to remember that you've got to get the playlists out as well, and the player doesn't have a lot of time to parse through really big, huge playlists each time it wants to play a short fragment of video. So, traditional HLS. In traditional HLS, the recommendation is for a 6-second segment. So basically, the encoder isn't going to give up anything for 6 seconds. So right there, you've got 6 seconds of latency. The client wants 3 segments in its buffer to have that, what it calls a nice, smooth runway. That's the Apple recommendation for HLS. And then if you're doing stuff at scale, you've got a lot of steps in between the encoder and the player. And each one of them is going to introduce some level of caching and therefore latency with those segments. So, best case, 30 seconds. I think you're doing well when you do 30 seconds in traditional HLS. So, and the other key thing I want to mention is not only are you looking at 30 seconds? But you're wasting a lot of time in between the encoder and the player. So, the encoder, you could argue, you like those 6-second GOPs. They give you a nice, good video experience. The player, it has that nice long runway. But in between is just lost time, basically, and something that is not going to give you low latency. So, partial segments. We've gone for 320 milliseconds. If you start breaking those segments down into 320 milliseconds, now you're really actually going to do something much different. And in theory, if you didn't have any if you had a very minimal caching and network latency, you're going to be pushing those parts down into the player in under 2 seconds. So, already just by going to parts, you've made a huge improvement, factor of about 12 times in your latency. And these are the part tags that you've got. One of the things that's interesting about parts, of course, is that they don't have to have an IDR in them. In our case, the first part always does have the IDR frame in it. That's the independent equals yes, which is indicating which of your parts have that. And then a segment's made up of a set of parts. So this is then what a full playlist will look like. You'll start out, not all of the segments are offered up as parts. So for the older segments, in this case, I'll get into why there's only 2, because that's the skip function. But the playlist starts with 2 full segments. We then move on to the next 3 segments have to be offered in parts. That's part of the spec. In our case, our segment size is 3.84 seconds. Our GOP size is 192, and our part size is 320 milliseconds. So altogether 12 parts in a segment, and 2 of those have the IDR frames in them. And then finally, right at the end of the playlist is where the parts come in independently. So in this case, the very last segment's just got 1 part ready for the player. Okay, so now what does this look like? So now you're getting those parts down into the client, potentially hitting 1.6 seconds, if you're lucky, got no latency in your network. But it's not good enough, really, because if you're trying to get to 3 to 6 seconds, glass to glass, you don't really have 2 seconds to waste in between the encoder and the player. And also, you haven't really given the player much of a buffer. So it's got to be faster than this. So what if you could get that part out as soon as it was ready? What would that look like? Well, now you're down to, somewhere in the range of half a second, which is starting to look pretty good. But one thing to be aware of with all of this, of course, is now you're making about 18 times more requests, because instead of looking for stuff every 6 seconds, you're looking for it every 320 milliseconds. And I think Will Law later today might be talking about CDN implications of this. Okay, so there's some other things now that help a little bit. You've got the blocking reload capability. So what happens, and this is another key thing. So we've got down to small parts, but how do we efficiently serve them? So the server can announce that it supports the can block reload equals yes in the tags of the playlist. And basically what that means now is that the client can make a request that looks like this. And what the client's saying is, give me a playlist, but give it to me when it has this segment, that part, and by the way, push me the part when it's ready. So what's key here now is the client is asking for the next part it needs directly in a playlist that's not cacheable. So this is going to go right through the cache and only be returned to the client when this particular playlist at this point is ready. Okay, so what does that look like? Now the client makes a request to the server, and the server is going to block that request until it has the part ready. One of the things that's interesting in HLS is the server is not going to return the playlist until the part's ready, because the spec says you can't put a part into your playlist until the part's ready to be served or to be pushed to the player. But you've got rid of a lot of that caching delay now between the client and the encoder. So from my perspective, from what we've seen, the HTTP push is really the key thing that makes low latency HLS work. We really see that actually does get us down to the kinds of time, latency that we're looking for a sports event. But there are a couple other things that you need to do as well. You want to also make sure that the playlist is not growing too big. So for a large sports event, you might have a rewind window. If it's tennis, you can have a rewind window of 8 hours if you're doing the whole day on center court at Wimbledon, say. So what happens here is you don't want a playlist with 8 hours of segments in it. It's going to be a lot to start shipping back and forth, especially every 320 milliseconds. So the skip parameter now, the skip tag in the playlist becomes really important. And that tells the client what's not going to be in the playlist. And basically, now the playlist only has to contain those very last segments. So it's only really telling the client what's happening near the live edge. The other thing that's really good is it's also telling the client what's happening near the live edge for the other bit rates. So with the rendition report, you're telling the client where to look for the live edge at the other bit rates, which means that switching bit rates becomes much more efficient in the client. Now, these features aren't specifically LL-HLS features, but they're really needed to make LL-HLS work. Right, so how do we fit it into our workflow? We've got a very standard workflow, nothing surprising here. Just to give you a bit of an idea of what we do, we use MediaXL for transcoder in this case, unified streaming for origin, Nginx is the cache. In this instance for low latency HLS, we've tested with Akamai and StackPath. And then finally for the player, we're using the Apple beta players. We've got an Akamai player that Will Law has produced, which I'll talk about in a bit, very kindly. And finally, DAZN has built a test app, which of course is key to being able to understand what's going on in the chain. Everything runs out of AWS Dublin, and we are based in London. So, what are the things we're doing? At the transcode, we burn in the timecode. It's a fairly easy thing to do. Our project is really looking at latency between transcoder and viewer. So we don't care. At this point, we're not doing end-to-end latency, so a burned-in timecode of the transcoder is telling us exactly where we're losing latency in the rest of that live pipeline. From the transcoder, it's chunk transferred CMAF into the live origin. And then at the live origin, we've had to add some layers for producing low-latency playlists. We use the globo.com M3U8 library, and we've contributed some extensions to that. We use that to produce the low-latency playlists. And then we've also tested at the origin, the origin's managing and everything in the 320 part size. And we've also tested using both the CMAF or transport stream parts. And in fact, both work equally well. The cache layer, we've tested the cache layer doing the request collapsing there. That's where we started. And putting the low latency playlist and the segment in URL in the link header straight out of the cache. But as we move forward, of course, we're doing that in the CDN. So we're looking to the CDN to do all the playlist blocking, not passing all those requests back up our chain. It wouldn't be sustainable, when you've got millions of concurrents running. And also the CDN is handling the HTTP push back down into the client. So finally, at the player, we've got the Akamai player, we've got the Apple AV player, and then we've got DAZN's written a nice little app, as I was saying, that allows us to do our testing. So let me talk a little bit about what we've done with testing. For stream validation, we're using Media Stream Validator, first port of call for validating live HLS streams. It currently supports some tests around low latency extensions, and this has proved very useful to start with. It didn't go deep enough for some of the more complicated issues, and hopefully we will expect to see some more releases and improvements in this space. We developed our own test scripts. We have one to check segments and part alignments across the bit rates. It's very important that that happens in the playlists. One to verify pushes are going out correctly and within the target time. Of course, they have to get pushed within that 320 millisecond. And the parts have to be announced correctly at the part interval. They can only be announced once they're available, so making sure that we've got that going. We instrumented almost everything. We log everything at this point all the time. We use the AV Player session ID, which can be used to correlate sessions in our logs, and particularly important once you've got the concurrent sessions running. And also, the web server gives some unique ID that correlates stuff as well for us. So here's a look at the Akamai Low Latency Test Player. So again, as I was saying, this is a shout out to Will Law, who's produced this and made this available for us. So this is our stream. You can see the burnt-in time code. You can see the wall clock coming out of the player. And then at the bottom, it tells you what latency it's getting. So just a little bit over 2 seconds, which is not too bad at this point. What's cool about this as well is those sliders that you play around to kind of manipulate what the player is up to and see if you can kind of pull that latency down. Doing things like reducing how many parts are in the buffer, et cetera, to see what else might be possible. And this is then the iOS app that we're testing with, that DAZN has developed. Here we're logging the AV Player error codes. And yes, they do occur. So playlist file not received. That's where the player hasn't received a playlist within the part duration. It's actually not a fatal error, but they will report. Obviously, it is an error, and it will be reported. The second one could not apply playlist delta. That's where the player is expecting something slightly different in the playlist than what it's getting back. That's an interesting error. It can sometimes be if the player's fallen too far behind the live edge, it's then getting stuff back in the playlist delta that really it can't use. So we do sometimes see that error as well. Right, so something a little bit about our findings. What can I tell you? HTTP2 push works. It really does reduce the latency. In the testing we've done, we can reliably achieve latencies of around 3 seconds at this stage. We expect to be able to tune that. One of the things at the moment is our encoder is still taking a second just to produce. We're wasting about a second just in the encoder. There's definitely some tuning we can do there. There's more tuning that we can do, through our stack as well. But it's not bad 3 seconds at this stage. And that's with a client buffer of about 1.5 seconds as well. So giving the client a fairly good runway there to get around rebuffering incidents. And we've shown that we can achieve these outside the lab. So using that Akamai HTTP2 servers, we've been able to demonstrate this from running the origins in Dublin and then having the Akamai edge servers in California. So we're demonstrating that both in that context, and also we demonstrated at IBC in Amsterdam. So it's not just a lab exercise. So, are we ready to ship it? Well, there's some problems with CDN HTTP2 push support. Not quite there yet. Plenty of CDNs are doing it, but probably needs to be more globally available. The player isn't really there yet. I mean, it's still beta. It is still changing. Some of the changes aren't, they're not backwardly compatible, so it's a bit risky to put stuff out at this stage. So that needs to, we expect Apple to be moving fairly quickly with this, but not there yet. Then there's some bigger challenges. One of the things we do is we regionalized the live streams, which is that we will actually substitute in parts from static files at different points in the stream. Not hard to do with, for HLS we were using 4-second chunks, not hard to do with 4-second chunks. A bit more challenging when you've only got 320 milliseconds to get that static content inserted into your live stream. We haven't tested yet with captions, closed captions, so we need to make sure subtitling works. And we haven't yet tested with the large DVR windows, so we do expect to see some issues there when the player's moving around between the live edge and the DVR window and moving back and forth. And also, what does the ecosystem look like with that going on? And finally, am I going to demo? No, sorry, guys. I'm not really going to go for the live demo here. So that's really, yeah. So basically, that's it. So finally, questions? Or if you're interested, we're also blogging about it. So there's perhaps a little bit more detail on our website at our blog. Thank you.